Welcome to part 2 of this lesson where we will pick up in problem 5.3, example 5.3. Okay, so now let's look at this question. We got a leak is detected 15 minutes after. So this is a number. Now, what they're telling us is that there was stuff in the container, radioactive contaminant. We don't know what it was. Now, they didn't detect a leak for 15 minutes, which represents this point on the graph. So we're going to use this as point 0. And why we're going to use this as 0? Because we don't have anything else to measure it from. We don't have any other measurements. So now, this time frame represents 2 jumps. And as we can see, each jump is half of a half, which is a quarter. So this must be 3/4. This is 1 1/4. This is 1 3/4. I should have probably left them as improper fractions. Why am I doing this? This is going to be important to go back to 0 and to write the expression. So we know we have to multiply going right. 7 times some number going right. So y equals a times b to the x power. Our a is 7 because that's where we're going to start from when a leak was detected. So how do we get from 7 to 3.5? I don't know. So if I'm not sure, I'm going to take my 3.5, I'm going to divide it by 7, I'm going to get 0.5, which equals 1/2. So that means this has a half-life of 1/2 hour. 1/2 is my b, x, where x equals 1/2 hour. Now, what is the time frame for 1/4 hour? If I take x and divide it by 2, that gives me 15 minutes or 1/4 of an hour. So let's write that 15 minutes. So each jump on the thing is 15 minutes. So I'm going to do 7, put this into the calculator, 1/2 to x divided by 2, where my variable stands for 15 minutes. I must do all this analysis before I start my problem. Once we put this into the calculator, we can do anything from there. So 7, 1 divided by 2, close the parenthesis, caret x divided by 2. And I go second graph. Now, my 0 is 7, 15 minutes. 1 jump is 15 minutes, 2 jumps is a half an hour. I'm at 3.5. My numbers work for every 1 full jump. So I can go back to -1 and find where I start, 9.8995. So at 0 time, before the leak occurred, there was approximately 9.9 micrograms of whatever material, about 10 grams. Now, I'm going to count the jumps from where we started our 0 at 7 to where C is. There are 1, now let's do this in a different color. There are 1, 2, 3, 4, 5, 6. So when x equals 6, I'm at C, which gives us 0.875. Now, we figured out everything on the graph. Now let's look at the questions. Okay, so how many micrograms of material after 1 3/4 hour? So we just calculated our y equals a times b to the x at 7 to the 1/2 to the x over 2, because x represents 30 minutes. And we want it for 15 minutes because 1 3/4 hours is 15 minutes. Well, it's 1 hour and 45 minutes, but we needed to get down to 15 minutes to get that. So when x was 6, y was 0.0 Now, 0.875 micrograms of material. Okay, what's the half-life of this material? The half-life of this material occurs in 1/2 hour jump. So the half-life is 1/2 every 30 minutes. So 1/2 of it loses every 30 minutes. So the half-life is 30 minutes. It disappears. Half of it disappears. Now, how does the decay rate from 1/4 to 1/2? So 1/4 to 1/2. Well, I had to change this one into 2/4. So because I times it by 2/2 to make the bottoms the same, equals 1/4. And then from 1/2 hour to 3/4, again, 3/4 minus 1/4 is 1/4. So we want to know what the decay rate is. So if my decay rate was 1/2 every 1 full half hour for 15 minutes, I got to raise that to 1/2. So what is the decay rate? This equals 0.71, 7071. So the square root of 1/2 is 71. So this equals 1/2 to the 0.5. It also equals the square root of 2. Not 2, I'm sorry. The square root of 1/2. And these all give you 0.71. Okay, now this graph gives us 0. So we have a 0, and now this is one full jump. Oops. This is 1 full hour from one point to the next point. So now when we look at a graph, we look at the outputs or the Y values. The X values represent time. The Y values are what's important for calculations. So 16 times what equals 8? Times what number equals 8? So I divide by 16 on both sides, and X equals 8/16, which is 0.5, which is 1/2. So my half-life is every hour. So now let's write our equation. We're going to start with 16. We went down by 1/2 every 1 hour, where X equals an hour. But look at our jumps. We have 1, 2, 3, 4 jumps. So if I take 16 to half to the X over 4 jumps, this gives me the half-life every 15, not the half-life, but yeah, the half-life every 15 minutes, where this half-life was every 1 full hour. Now, I can ask you about any point in between once we understand how to change the time, the variable, into any unit I want it to be. By what factor does the mass decay every hour? For every hour is 1/2, that was our half-life, to the 1, so the change was 1/2 every hour. All right, for each pair of points, draw a line. So we're not doing that, because these are full jumps. So we're going to get an even display. That's 2 full jumps. So that's going to be the factor over 2 hours. So the factor over 2 hours was 2x, or 2 times 1, or just 2, not 2x, just 2. So 1/2 squared. So 1/2 squared equals 1/4. And that's the factor over 2 jumps. But 1 jump is 1/2. The factor is 1/2 to the 1. 1 to 2 is 1/2 to the 1. Between hours 19 and 20, that's a 1 hour jump. So it's just half of it's going to go away.